Hello guys, very good morning one and all. Yesterday's lecture we have seen the symmetric section numerical. We have taken the I section. In today's lecture, we'll see the unsymmetric section in buckling of column. If you have given the unsymmetric section, then how to find out the buckling load, or we can say the coupling load, or how to find out the buckling stress or crippling stress. In today's lecture, we will solve this numerical. We will solve the two numerical. First given on the K section and second numerical is given on the rectangular section. We will see the one by one. See the first, here is a, you have given the T section. In that T section, you have given the size of top plane is 100 by 10 mm, and web is given the width of the web or thickness we can say 10 mm, and the depth is given 70 mm. Okay, and you have also given the end condition. See, we have seen there are four end conditions. Here end condition is given hinge at both ends. Okay, and so what is the meaning of that? Hinge at both ends. We have seen this is the one table. In this table we have seen if the hinge at both ends, then what happen? What is the relation between the actual length and effective length? LE is equal to L is there. LE is equal to L is there. Remember that in this table, this is the first condition, end condition, hinge at both ends. Remember that. Effective length is equal to actual length. Also, you have given the strut length is 3 meter. Strut length is given 3 meter. Okay, I will convert it to mm. 3000 mm. This is the strut length is given. You know that what is mean by strut. Also, you have given the end modulus 200 giganewton per meter square. How to convert it to MPa or Newton per mm square? We know that 200 into 10 raised to 3 MPa, or we can say the Newton per mm square. Okay. Use Euler's formula. With the help of that, we want to solve using Euler's formula. You know the Euler's formula. What is the Euler's formula? I have told, think reversely. What we want to find out? We want to find out the buckling load. What is the formula for the buckling load? Yes, anybody? PC is equal to pi square EI divided by L square. This is the buckling load formula. Okay, already we have seen pi square EI divided by L square. Pi is known, the value. E also given. E is the Young's modulus 200 into 10 raised to 3 Newton per mm square. I is the least moment of inertia. Okay. Last lecture you have given the symmetric I section. But if you have checked this section is a unsymmetric. If you have taken the half section, then above or below we don't get the same. Okay, that's why the given section is a unsymmetric section. Then how to solve this? We want to find out before going on that which theorem we want to use. In unit number 3, we have seen if you have given unsymmetric section, then you have to use parallel axis theorem. Okay, parallel axis theorem. Then how to use that parallel axis theorem? We know that. Okay, first we want to consider the, suppose there is a two parts are given. I will mention here. This is the first part and this is the second part. You can consider also this is the first part and this is the second part. No problem. You will get the same answer. First we want to calculate the position of that neutral axis. Position of the neutral axis. Okay, or position of the centroid. How to calculate that position of centroid? Because this is the unsymmetric. Y1 is equal to, we know that A1 Y1 plus A2 Y2 divided by A1 plus A2. We have seen this formula in the unit number 3. A1 Y1 A1 means what? Area of the first portion of or component, and A2 is the area of the second component. Okay, what is the y1? Y1 is the distance from the neutral axis to the topmost component. Okay, topmost to the neutral axis. That distance we want to calculate. Okay, then how to calculate that? Can I write here that all value? See, because we will find that value again when you find out the Ixx. Okay, moment of inertia about the xx section. A1 we are consider this is the first part. Flange is the first part. A1 is 100 into 10. What is the area of that? 100 into 10. You will get the 1000. Right? What is the unit? Mm square. 1000. Okay. What is the y1? Y1 is the centroid of that body. Okay. This component. Don't think about the second component. Think only about the first component. What is the centroid of that? This one. Means you have to take this half distance. This is the y1. This is the y1. Y1 is equal to, I will write here 10 by 2. You will get the centroid of the first component. 10 by 2. You will get the 5 mm. Then what is the A2? What is the A2? Area 2 is equal to area 2. Think about only second component. Don't think about the first component. Okay. What is the B? B into D? 10 into 70. 10 into 70. You will get the 700 mm square. Right? And what is the Y2? Okay. What is the Y2? You have to take the centroid of this. Okay. Second component. 70 by 2. 70 by 2 plus this 10. Why 10? Because from the topmost. Okay, where is this centroid of this? Suppose here is the centroid of this second component, and you have to calculate this distance from the top or from the bottom. You will get the y2 distance. Okay, how are you getting? From the top you have to calculate the distance from the centroid of that component from the top. From the top. This is the meaning of y1 and y2. Instead of this 35 plus 10, you will get the 45 mm. Okay, once you have calculated the all value, then you have to put this value in this equation. Y bar is equal to A1 Y1. Check that. I will put here A1 1000. Then Y1 is 5 plus A2 700 into Y2 45 divided by A1 Y1 A1 plus A2. Then this one A1 plus A2. This is the Y bar top. Okay, why top? Because we are start from the top. If you start from the bottom, then you will get the first Y bar bottom. Y bar bottom. Okay, remember that. Then this value you will get 21.47 mm from the top. Okay, and if you calculate Y bar bottom, how to calculate the Y bar bottom? You know that we have seen this total depth. Total depth is given 10 plus 70, 80 is there. 80 minus this one, 80 minus 21.47 means Y bar top. You will get the 53 mm. We will get the both value Y bar top and Y bar bottom. Okay, where is the Y bar top? Suppose I will mark here. Okay. We have the Y2 value is 45. This below that you will get this one. This is the centroid of that body. Okay. This is the Y bar top, and this one is a Y bar bottom. For the unsymmetric section, we have the value 21.47 and 58.53 mm. If you have made the summation, then you will get the total is 80 is there. Once you have calculated, We have seen already in the unit number 3. Okay, then this is the revision for you from the unit number 4. Once you have calculated the y bar, then next step is what we require. We know that we want to calculate the I. How to calculate the I? This is the unsymmetric section. Use the parallel axis theorem. Then I will write here moment of inertia about section with section xx. Then we want to calculate ixx. What is the parallel axis theorem? For the here the two parts are given. Okay, that's why you have to write bd cube by 12 plus ax square. Again, what is the h? What is the h? H is nothing but the difference between the centroid and y1 distance, y1 square. For the first part, remember that y bar minus y1 plus what is the second part? Again, bd cube by 12 plus area y bar minus y2 part. Okay, what is the formula for this? I have simplified that formula. We have seen already ixx is equal to, what is the parallel axis theorem? bd cube divided by 12, or I will write cg plus ax square. What is the cg? Cg again for the rectangular part, bd cube divided by 12. What is the area? Area of the first component. Okay. What is the h square? H square is nothing but this distance y bar top to the y1. Means this remaining distance is a h. This distance is a h. Already I have told to calculate this. Then we want to put the value. I will put the value here. bd cube by 12. What is the b for the first component? Which is the first component? Don't change this component. If you have once consider that component, this is the first and this is the second, keep as it is. Don't change. Okay. If you have for starting, you can change. This is the first and this is the second. But if you have considered once, then don't change. Then bd cube divided by 12. What is the b? 100. What is the d? 10 is there. 100 into 10 cube divided by 12 plus what is the area of the first part? We have calculated 100 into 10. 1000 is there. 1000. What is the y bar? You should take y bar top, because we are starting from the top. 21.47 minus what is the y1? 5 mm. Means what is the y1? y1 is a 10 by 2. Again, you will get the 5 bracket square. Okay, this is the for the first part. And what is the second part? Plus. What is the second part? Yes, anybody tell me what is the second part? B value and D value. 10 into 70. B is the 10 and 70 cube is there divided by 12. Plus what is the area? 700. We have calculated here two values 700. Then what is the value of y bar? 21.47. This. And what is the y2? 70 by 2 plus 10. 45 here. 45 square. This is for second. If you have calculated this, then you will get the ixx is equal to, check that, 953 into 10 raised to 3. What is the unit? Mm raised to 4. This is the moment of inertia above the neutral axis or section xx. This is the moment of inertia. Okay, this is for unsymmetric section. 953 into 10 raised to 3 mm raised to 4 is there. Then we want to choose the list. That's why we want to calculate the Iyy also. What is the Iyy for the given body? Check that. We have taken xx section. Here we will take the yy section. This is symmetric or unsymmetric? Check that. This side and this side. From the center, you will get the same part. Means you will get the mirror image. Mirror image. This symmetric is there. here is a no need to use the parallel axis theorem. Parallel axis theorem, right? When we use the parallel axis theorem, if given figure is a unsymmetry, or if you have calculate ixx, okay, xx section, if you have calculate yy section, then check that you will get the mirror image or not. Then Iyy is equal to, you know the what is the formula for the rectangle? db cube divided by 12 plus db cube divided by 12. This is for second, this is for first. What is the d for the first component? What is the d? 10 is there. What is the b? 100 is there. Okay, put the value 10 into 100 cube divided by 12. This is for first part, plus what is the d for the second part? 70, and b is the 10. 70 into 10 cube divided by 12. This is for second. If you calculate that do the calculation, then you will get the Iyy is equal to 839.17 into 10 raised to 3. What is the unit? mm raised to 4. Take that. If you compare this 2 to 1, okay, this one and this one, then which is the least? We require the I least. Okay, this remember that. Don't confuse. You have to calculate both Ixx and Iyy. Which is the least? This means minimum value from this to this Ixx or Iyy. Yes, Iyy is least. Then we are using for the calculation this Iyy is the least moment of inertia. This value is a 839.17. You have to put in this equation. Okay. We know the equation, all value we have, then put this value in this equation, then you will get the buckling load. Pi square as it is into what is the E? E is a 200 into 10 raised to 3. What is the I list? 839.17 into 10 raised to 3 I list. Then check that next value is a L square. L is square. Here is a condition is a effective length is equal to L, because both ends are hinge or pin. Okay, that's why you will get here what? See, meter means 3000 mm square is there. Then if you do this calculation and check what you will get this value, you will get the 184 into 10 raised to 3 Newton. Okay, if you calculate this value, do the calculation and check you will get this value or not. Or also we can write 184 into 10 raised to 3 means 1000. We can write the kilo Newton is there. What is the unit of force? Newton is there. Load in Newton is there. Then you can convert into 10 raised to 3 means 1000. Then you can write the kilo. Okay, all of you getting how to calculate? Very simple. If you know the knowledge of the unit number 3, then easily you can calculate the unit number 4. Okay, the value you can calculate easily for the unit number 4. Check that only the additional is this formula and condition only. This is equal to pi square EI divided by L square. Okay, that's it. Then we will see continue the second numerical. Okay, all of you ready? Yes, any doubt? Okay, good. Then second we will see what is the given in the second numerical. Check. There is a rectangular. You have given the rectangular component is given, right? This rectangular component, you have given the size 70 by 90 mm. B is given 70. I will write here. B is given 70 mm, and B is given, depth is given 90 mm. Okay, and end condition is given both in pin. Okay, here they are using the word hinge. Hinge and pin are same word. Don't confuse. Means you have given the condition, this is very important. If the both ends are hinged or pinned, then what is the relation between the actual length and effective length? This is the LE is equal to L. Remember that. This relation is very important. If you write the wrong formula for that relation, your whole numerical is wrong. Okay, you don't get the correct answer. Then what is the, then again they have given the E is equal to 210 GPa, convert it to MPa. 210 into 10 raised to 3 MPa or Newton per mm square. Then what we want to find out? Find the PC value and sigma C value. What is the PC again? Buckling load. And what is the sigma C? It is the buckling stress. Okay, we want to find out this value. Then how to find out this value? Yes, you know that we know the PC is equal to what? Okay, think reversely. What we want to find out? PC is equal to what? Pi square EI divided by L square. And what is the sigma C is equal to? This is the PC divided by cross sectional area. PC divided by cross sectional area. First, then say sigma C is equal to PC by area. Area is known for that rectangular bar. Okay, but we don't know the PC value. That's why we want to calculate first PC value. Then how to calculate that PC value? You know that PC is equal to, again same. You have to calculate. Here is no need to calculate the value of y bar, because this is the symmetric section, both sides. If you have taken the this or this side, okay, that's why you take that. You have to calculate directly Ixx and Iyy for the given figure. Ixx is equal to what for the rectangular bar? BD cube divided by 12. What is the B? Is 70. What is the D? Is 90. Cube divided by 12. Then if you calculate this BD cube divided by 12, then you will get the 4252.5 into 10 raised to 3 and then raised to 4 is there. Okay. Once you have calculated this value, then again we want to calculate the least moment of inertia. We require which value? This Iyy. Yes, Iyy. What is the formula? dB cube divided by 12. dB cube divided by 12. What is the D? 90 mm depth. What is the B? 70 cube divided by 12. Okay, you will get the idea which is the least one. 2572.5 into 10 raised to 3. If you have calculated, then check these two values, this one and this one. Which one is the least value? Iyy. Iyy is equal to I least is equal to, can I write 2572.5 into 10 raised to 3 mm. Mm raised to 4 is there. This is the least value. Then check that we have all the value or not. L is equal to, L is there. Okay. For the second numerical, check that we have given the LE is equal to, L is there. This LE value is given, LE value is given 2600. L value is given 2600. By mistake I have not written there this value. L is given 2600, mm is given. Okay, means we have all the value. We'll put that value in this equation. Pi square E is equal to what? This is the given 210 into 10 raised to 3. What is the I? This moment of inertia. 2572.5 into 10 raised to 3 divided by what is the LE value? LE is equal to L. This equation is very important. These marks are divided stepwise. Okay, so if you have written this LE is equal to L, if this numerical is asked for the 6 mark, then you will get the 1 mark for this relation. LE is equal to L is equal to 2600 mm is there. Okay, then what we will get, this PC is equal to, you will get that this value 788, this value you will get 788.73 kilonewton is there, okay. If you have calculated, then you will get the 788.73 kilonewton is there. Then once you have calculated the PC, easily you can calculate the sigma c, okay, buckling stress. How to calculate that buckling stress? PC divided by area. What is the value of this 788.73 into 10 raised to 3? I will write in Newton. Okay, here is a, we have to convert into the Newton, means 10 raised to 3 Newton is there. Divided by, what is the area? What is the area of that rectangular portion? Box 70 into 90. 70 into 90. Okay, right? Then, if you have calculated this, then you will get the 120.5 Newton per mm square. If you have kept as it is this value in kilonewton, then you will get the kilonewton per mm square. Okay? What is the unit of stress? Newton per mm square. Then you will get the 120.5 Newton per mm square of MPa. Okay, all of you getting? If you have asked the question on the Euler's formula, then there is only one formula, pi square EI divided by LE square. Okay, and you should remember that 4 conditions: both end hinge, okay, one side fixed and other is hinge. Third is a both end fixed, okay, both end fixed, and last is a one side is a hinge and one side is a fixed. Okay, you should remember that 4 conditions and see the relation in between actual length and effective length. Today we will stop here. Next lecture we will cover the numerical on the Rankine-Jordan formula. Okay, sometimes in the examination you will ask the question on both. You have to solve the numerical with the help of Euler's method as well as a Rankine method. Okay, we will see the combined numerical in the next lecture, and we will finish the half part of the unit number 4, buckling of columns. Today we will stop here. Thank you.